Use the first principles to differentiate gx equals x squared minus x. Now, just quickly, this gx is just the name of it. It's still the same type of function. It could have been fx, it could have been hx, it could have been whatever. We only usually use gx if there's already an fx, so don't let that confuse you. What you need to remember is the moment you see used first principle, you immediately write down the rule. The rule is that differentiate, which means m, which means the derivative of gx equals, and you're going to say the limit where h strives to 0 of fx plus h minus fx divided by h. That's the rule. You have to write it down. Now, I like to do my things separately, only because it gives me more space to work, and it's less writing. But you're welcome to do everything in one. It's just a lot of writing. What I want to do is I want to find fx. Now, fx in this case is going to be gx. Doesn't matter how you write it. I just remember the rule. Okay, so I'm going to start off by saying gx equals x squared minus x. Now I want to find what is gx plus h. So I'm going to say g of x plus h equals, wherever there's an x, wherever there's an x, I'm going to put an x plus h. So I find it easiest to say there's an x squared minus an x. And what is that bracket now? It's not x anymore. It's x plus h, x plus h. The reason I put a bracket there is otherwise you're going to mess up this negative. If you just say negative x plus h, you're not going to take into account that that negative needs to go into the h as well. So use brackets when you do the substitution. So what I'm going to do is I'm going to multiply out now. I'm going to simplify this by saying x plus h times x times x equals x squared. X times h is xh twice, so it's plus 2xh. H times h is plus h squared. This negative needs to go into both of them. So minus times x is negative x. Negative times h is negative h. My next step, I have now fx or gx. I have gx plus h. Let's combine the two. Because if I don't do it here, I have to do it here, and I have to carry the limit. So it's just more writing if you want to do these steps over there. I'm going to now see what is gx plus h, take away gx. That is that step. Okay. I know one way to do this is to write as gx, x squared plus 2xh plus h squared minus x minus h. And then I'm going to write this underneath under the same thing. So it's going to be x squared minus x. And if I subtract, remember positive becomes minus and a negative becomes positive. So you can see this is going to cancel, that's going to cancel. What I'm left with is 2xh plus h squared minus h. So I have done now this step. All I have to do is now I'm going to say this equals, and I'm going to carry the limit because I have not replaced the limits. Now if you can remember limits, I could not substitute 0 in there because I'm not allowed to divide by 0. So I still have to show that I need to find a limit. What do I need to find a limit of? I need to find fx plus h minus fx, which is this value. So this is going to go in here now. I'm going to say it's 2xh plus h squared minus h divided by this h. I still cannot substitute 0 in there because I'm not allowed to divide by 0. At this stage, after you've done this, there should be an h in every term. Otherwise, you've made a mistake. So I'm going to carry the limit because I have not substituted h yet. At the top, I'm going to take out h as a common factor, which gives me then 2x plus, if I took out 1h remains, and minus 1. Don't just throw that away. Because if I multiply back, I need to get that. That will give us 2xh. That will give us h squared. That will give us minus h. Divide by h. Now I can say, but this h, because I've got one term at the top, this h can cancel with that h. Once I've done this, I can substitute 0 in the place of h because I'm not dividing by 0 anymore. So this 0 will be substituted, and I'll say 2x plus 0 minus 1, and that gives me the answer of 2x take 1.